Hello everyone, welcome back. So today we will be looking at this LeetCode daily problem and one more Codeforces problem which use the same trick. I don't know if saying that technique as a trick is appropriate or not, but let's see how it goes. So here's the problem. I recommend you to solve it on your own. Okay, try it on your own, and if you are unable to do so, here's the solution and the trick involved. Okay, so you are given 2D array points of size n cross 2. So some jargon. So basically you are given points on 2D coordinate plane, and you have to count the pairs of points such that first point is on the upper left side of the second point and any other point doesn't lie in between them. So basically on the border or inside the rectangle that uh, those 2 points make. Okay, so to understand it more clearly, let's take a look at these sample test cases. So here we are given 3 points. 3 points are marked very nicely here on this coordinate plane. As we can see, output should be 0 because there is no pair of points such that one point is on the upper left side of the other. Okay, so taking into consideration the second sample input, here we can see that as these 3 points are given, so these 2 points do form a valid pair because this point is on the upper left side of this point and any other point doesn't lie in the rectangle that these 2 points make. um, so same for these 2 points, but if you consider these 2 points, the 6 comma 2 and 2 comma 6, the first point is on the upper left part of the second point, but as we can see, there is one more point lying inside the rectangle that they both make, so it's not a valid pair. So that way output is 2, and likewise you can verify for this test case the output is going to be 2. So these 2 points and these 2 points. So one more edge case to notice is that so this is not a valid configuration taking into account 1 comma 3 and 3 comma 1 because 1 comma 1 lies on the border. The any other point should not lie inside the rectangle or and on the border of the rectangle, so it should be completely excluded from that rectangle. So as we can see, constraints are like the number of points are up to 50, so we can very well write the order of n cube or maybe order of n power 4 solution, but order of n cube suffices as we are gonna see. So what I can notice here is that so I can basically brute force. I can take any 2 points. So let's go to the whiteboard. So suppose these are my sum points. So what I can basically do is that so I'll start from this point. I'll check for all these 3 points that if this point lies on the upper left part of these points, the point which we are considering, and any other point should not lie inside the rectangle that they make. So considering this point and then this point as a second point, this will form one valid pair. Then this point also they form valid pair. So if we consider this point, uh, they don't form valid pair because this is the rectangle that they make and this is the point that they include, so these two don't form valid pair. So going forward, considering the second point, so 2 points. Now let's consider this point. Okay, so for this point, this is the only point which satisfies the condition, so +1 to our answer. And for this point, any other point doesn't like uh, guarantee you the condition, so this won't have any contribution to the answer. And taking into account this point, so all the other points are actually paired with this point in the previous iteration. So in this case as well, we won't get any meaningful contribution to our answer. So our answer in this case would be 3. Is it 3? Yes, it is 3. So that is how we are gonna proceed. So the trick here is that, so this is the most important part of the video. So implementation of this problem, like implementation of the solution, is pretty easy. Like you just do 3 for loops and check the conditions. But how do you check that a pair of point a comma b such that a is like on the what you can say, a is on the upper left part of the b. So this is a, this is b. How do you check this efficiently? Like if you are gonna write 4 if cases, like that's too cluttered, right? Your code looks bad and you run into some edge cases, and we definitely don't want that. So what we can do here is that, one thing to notice that uh, if this is the configuration that they lie in, then the slope of the line which connects these 2 points must be negative or 0. So basically less than or equal to 0. If it gets positive by any chance, then these two don't satisfy the condition. So the trick here is that just check the slope by our formula. So y2 minus y1 by x2 minus x1, this is the slope formula for any line, or basically the segment here. So again you'll ask, then what about x2 is equal to x1, x2 is equal to x1? We again have to write more if conditions to validate that, right? So not the case here. So what you can do is that, so if y2 minus y1 divided by x2 minus x1 is less than or equal to 0, then you can guarantee that y2 minus y1 into x2 minus x1 will be less than or equal to 0 as well. So you can prove this easily, no worries. So this is the trick that we are gonna use. So we will check y2 minus y1 into x2 minus x1 is less than or equal to 0. If it is, then only these points will satisfy our condition. Of course we still want to check that if some other point lies inside this rectangle or not, but that's a further part. That's further part. First of all, if this expression y2 minus y1 into x2 minus x1 is greater than 0, then you for sure know that your slope is positive, and these 2 points won't guarantee you, these 2 points won't guarantee you the condition that you are searching for. Okay, so this is basically the trick, and let me show you the code real quick. So implementation is pretty straightforward. It was just about the trick. This only one if statement suffices. Like you don't have to worry about the edge cases and stuff. So yes, n is the size of the input vector given. I'm copying it down to some dummy vector v, so that inadvertently I don't make any changes to the input vector. So yes, pretty simple code. You just iterate over I is equal to 0 to every point, then all the points which are after that point in the given input vector, and you check this condition. If the slope is greater than 0, you just continue. Otherwise you check that uh, that for every point, oh, you just skip for the point being equal to I or j, and for every point you just check if if it lies in the rectangle or not. If it does, then possibility of these 2 points satisfying the conditions I comma j, like I comma j satisfying the condition, is not true, basically false. And if after all these checks, if possibility is true, we just increment our answer, and finally we just return our answer. So that is basically the point and the trick here. And one more problem which I came across um, to use this trick was this. So a pretty old problem, educational round 140, maybe 2 years, 2 3 years back, who knows. So let's see. You are given a non-degenerate triangle. Non-degenerate triangle is triangle with positive area, of course, and you are required to draw a straight line which should be vertical or horizontal, such that it cuts the given input triangle into two non-degenerate triangles. Okay, so these are some proper ways to cut the rectangle, and for these three rectangles the output should be yes. And for these rectangles, so for this rectangle also output should be yes, but you can't draw the line as in this way, because it is like the figure of four sides, and it is not basically the rectangle. And here it is not getting cut into two parts, and here your line is not vertical or horizontal. So yeah, logic here is pretty simple. So logic here is that, so you must not have the right angle triangle of which sides align with the coordinate axis, right? Like this, or like this, or like this, and one more triangle. What am I missing? Yes, this triangle. Okay, so if you have any of these four triangles, so basically the sides which are coinciding with the vertical and horizontal lines, aligning with the vertical or horizontal lines, then no matter what, how you try, you like can't draw the lines to split the triangle into two non-degenerate triangles. So again, how do you check that the slope of the two lines is 0? So if slope of two lines is 0, so basically slope of not slope of two lines is 0, slope of like um, lines is infinity or 0, right? So slope of one line should be infinity and slope of the other line should be 0. So in this case our answer would be no, otherwise our answer would be simply yes, right? So here also you can check that slope is calculated by y2 minus y1 divided by x2 minus x1, and if it is infinity, then x2 minus x1 needs to be 0, or if it is 0, then your y2 minus y1 should be 0. So combining these two conditions again gives that y2 minus y1 into x2 minus x1 should be 0, right? So in this way you can count the slope of the lines, count the lines having slope 0 or infinity. Let me show you code real quick. So just taking the input and initializing the count variable, and yes, again iterating in the same way as we did in the LeetCode problem, and checking the condition that y2 minus y1 into x2 minus x1 is 0 or not. If it is, incrementing the count, and if count is less than 2, our answer is yes. And if count is greater than or equal to 2, it will be 2, it won't be greater than 2, as because the given input triangle is also non-degenerate. So in that case we output no. So basically n and non are some uh, defines. So n is outputting yes and the backslash n, and non is outputting no and backslash n. So yes, it is neat trick and I thought I should share it with you all. um, so I hope you gained some value after watching this video. Yes, stay tuned for more. Thank you for watching video for this long time. See you again. One more thing, uh, the links for the problems and the solutions are attached in the description, so do check that out. Yeah, sure. Bye bye.